Now, to give a mathematical treatment of the interference phenomena, we consider two sinusoidal waves because both of them are sinusoidal waves. Consider two sinusoidal waves. Sinusoidal waves having same amplitude, such that they have the same amplitude but different phase constant, but having different phase constant. One is phase constant phi1 and the other has phase constant, I call it phi2, and both are traveling in positive x direction. These two waves will be one I call it y1, which is a function of both position and time, which is equal to a sine kx minus omega t, and the other wave is y2 minus omega t minus phi1. This is the phase difference of wave 1. Similarly, the second wave, which is y2, which is a function of both position time, and we already mentioned that they have the same amplitude, so the amplitude of both these waves are the same, and they are also moving in the same direction, so we have sine kx minus omega t, but they have different phase constant. This is a phase constant, a phase difference, a phase constant phi2. So this wave has a phase constant phi1. This is called phase constant, and this is also a phase constant, which I represent by phi2. Now, in mathematical language, we call superposition to the interference of wave. Like interference of wave is basically the superposition. So we can write the resultant wave, which is I represent by y, which is a function of both position over time, which is equal to the sum of both y1 and y2. So this is the resultant wave, which comes from the superposition of these two waves, y1 and y2. Now next, I will put the value of this y1 and y2 from equation 1 and 2. I call it equation 1, and this is equation 2. And using equation 1 and 2, we have y, the resultant wave, which is equal to a sine kx minus omega t minus phi1 plus a sine kx minus omega t minus phi2. Now the amplitude is same, so we can keep it outside or take it constant, common, which is a into sine kx minus omega t minus phi1 plus sine kx minus omega t minus phi2. Now we have a trigonometric identity, which is sine alpha plus sine beta is equal to 2 sine alpha plus beta divided by 2, and we have cos alpha minus beta divided by 2. So using this identity, then equation 3 becomes y, the resultant wave, will be equal to a, this is sine alpha and this is sine beta. So we have factor 2 here, so I'll keep it outside, and then we have sine alpha. Alpha is kx minus omega t minus phi 1 plus beta, which is plus kx minus omega t minus phi 2 divided by 2. And then we have cos alpha minus beta. So cos alpha is kx minus omega t minus phi 1, and then we have minus beta minus kx plus omega t plus phi 2 divided by 2. If I simplify it, then we get 2a sine kx plus kx, we have 2kx, omega t minus omega t, we have minus 2 omega t, and then we have minus phi 1 minus phi 2. I call it minus phi 1 plus phi 2 divided by minus phi 1 minus phi 2 divided by 2. And then we have cos. So this plus kx cancel with minus kx, minus omega t cancel with plus omega t. So we have cos phi 2 minus phi 1 over. I can write it as y, which is a function of both position and time, is equal to 2a cos phi 2 minus phi 1 over 2, and then we have sine. So I will apply this 2 here, so this 2 cancel with this 2, this 2 cancel with this 2. So we have sine kx minus omega t minus phi 1 plus phi 2 over 2. This is the resultant wave. I can write it in more simplified form, y, which is a function of both position and time, which is equal to 2a cos phi 2 minus phi 1 over 2. And then we have sine kx minus omega t minus phi 1 plus phi 2 over 2. I can also write it as 2a cos del phi over 2. And then we have sine kx minus omega t minus phi 1 plus phi 2. I call it, this term I call it phi prime. Where del phi is equal to phi 2 minus phi 1, and phi prime, I call it phi 1 plus phi 2 over 2. I replace this phi 2 minus phi 1 by del pi, and then this phi 1 plus phi 2 over 2 by phi prime. So our final expression is this one. I can write it again in here. The final expression is y, which is a function of both position and time, is equal to 2a cos del phi over 2 into sine kx minus omega t minus phi prime, where del phi is phi 2 minus phi 1 and phi prime is phi 1 plus phi 2 over 2. Now this equation, I call it equation number 4. Now this equation 4 shows that the resultant of superposition of sinusoidal wave, because the resultant of this resultant is a superposition of two sinusoidal waves. One sinusoidal wave is this one and one is this one. We have the resultant is this one, so the resultant is also a sinusoidal wave with amplitude. Now here the amplitude was a sine kx minus omega t minus phi 1. So here the amplitude is this one. the amplitude is I call this the amplitude of the resultant is ym, which is 2a cos del phi over 2. This is equation number 5. This is the amplitude of the resultant wave. Now this amplitude depends on this cos del phi over 2. If we have the value of this cos is 1, we call it constructive interference. If its value is 0, we call it destructive interference. So we will discuss both the constructive interference and destructive interference in the next video.